blockchains, and algorithms. Before we go any further, what is an algorithm? Computers know what to do because they have written lines of instruction called code. And before you can write code, you need an algorithm. Basically, an algorithm is a list of rules to follow in order to solve a problem. As already stated, before blocks can be added to the blockchain, they have to be validated. There are many different types of block validation, or in tech terms, consensus algorithms. These algorithms are the cornerstones for every blockchain network and keep the network in harmony and not in chaos. Blockchain has many characteristics, including decentralization, stability, security, and non-modifiability. And the consensus algorithm plays a crucial role in maintaining the purpose, safety, and efficiency of each blockchain. None of the consensus algorithms are exactly the same, although a few share similar concepts. Here's a brief overview of the top 10 most popular algorithms and a sample of which blockchains use them. Number 1. Proof of Work, used by Bitcoin, Ethereum, and Monero. Bitcoin's founder created proof of work, where miners configure their computers to solve very intense puzzles in order to create the next block. When they solve that puzzle, i.e. with Bitcoin once every 10 minutes, they are given a reward in either coins or tokens. Bitcoin has become so valuable, entire countries are setting up huge factories to create blocks and claim rewards. Places that have free power have a tremendous advantage, as the machines required to mine these blocks suck up unbelievable amounts of power. A decommissioned power plant in Australia was recently purchased solely for the purpose of Bitcoin mining. The pros of proof of work are that anybody can make money from their idle computer. The amount depends on which coin, the type of computer, and cost to power it. There are special mining computers which are solely made for mining cryptocurrency, called ASICs. If you are trying to compete against miners using specialized mining hardware, it may not be profitable to even try. The cons of proof of work are that proof of work is slow and blocks occur every few minutes or whatever the code defines. Proof of work is very un-eco-friendly, and many profitable coins are now dominated by large companies that have sprung up for the sole purpose of mining these coins. For instance, Bitcoin or Ethereum. If any one or two companies have more than 51% of the hash rate, think of it as blockchain speed, they essentially are now in control of the chain. This could infuse a new code with different rules, causing the chain to split, with many network nodes configured automatically to stay with the biggest chain. And this is known as a fork. Number 2. Proof of Stake, used by Neo, Dash, and Navcoin. With proof of stake, instead of mining, people who hold the coins belonging to the network have the option of being minters. A designated third party creates the blocks, which allows the minters to run software on their computers that act as validators. It's much less energy intensive and requires no special hardware, just coins. The more coins you have staked in the blockchain, the higher the chance you have at being selected at random to validate a block. The pros of proof of stake are that any coin holder can be a validator, as long as you are willing to lock up your coins and not spend them. Proof of stake is much more energy efficient and much faster, and there can be several blocks per minute. Proof of stake is much safer, as to perform a 51% attack, you would need to have 51% of all the coins, and attacking the network would only cause your own investment to be depleted. The cons of proof of stake. Your coins are locked up in a deposit when you are minting, but you can pull them out at any time. There are some complex theoretical ways to still attack this type of network. Number 3, delegated proof of stake, in use by EOS, BitShares, and Lisk. There is a major difference in this system as compared to the previous two, as instead of everybody having a chance at validating a block, only a small number of machines on the network are selected by a vote. This way, it is much easier for a handful of computers to talk to one another, to compare blocks and validation in a much more efficient way. If one validator starts to fail, they are voted out of circulation and replaced by another computer on the network. Instead of miners competing with each other, in delegated proof of stake, or DPoS, they all work together to solve the block puzzle, creating blocks much, much faster. The pros of delegated proof of stake. DPoS is fast. Blocks take less than 1 second to be created. The entire network is working together instead of against each other. And this type of network is much more easily expanded since it is so much more inclusive. Cons: that this system is partially centralized and controlled. Number 4, proof of authority, as used by the POA network. The proof of authority consensus algorithm is pretty much the same as the client-server relationship. There is one authority in charge of everything, and the clients can just read the information if they're allowed. This is best used in private corporate chains. Additional conditions to become an authority can be specified, including identity management and verification, in contrast to the previously mentioned algorithms, where the only identity on the network is often a wallet address or IP address or port. The pros of proof of authority are that it is fast, reliable, and trusted. The cons of proof of authority are that the community has no vote or control, and the creator of the chain can implement updates at will or decide not to create any updates at all. Number 5, proof of burn, as used by Binance Coin, Counterparty, and Slimcoin. The concept of proof of burn is the following. Instead of being rewarded for solving puzzles, the miners are meant to send coins to an irretrievable address to be lost forever. The concept is by decreasing the supply of coins, the value of the remaining ones increase. More often than not, the practice of burning coins is something done by the developers rather than the community. Blockchain ICOs, or initial coin offerings, often burn any unsold tokens remaining. Binance burns some of its profits every quarter to ensure its coin gains value. The pro of proof of burn is that scarcity drives the value of the remaining coins up. The cons of proof of burn are that once the coins are burned, they are lost forever, which helps the ecosystem. But there is no direct reward to miners for burning coins. Number 6. Directed acyclic graph, as used by IOTA, Hashgraph, and Nano. Participants in this network that want to send a transaction are first required to do a small proof of work, in which they verify 2 previous transactions that occurred before. Unlike traditional servers, the more users that are logged on, the faster the transaction speeds get. In theory, this tangle can accelerate to near instant speeds. Each of the blockchain rewards that use Directed Acyclic Graph, or DAG, has their own unique take on how to organize transactions. So, if you want to know more about this type of algorithm, you should read a lot more about it. The pro of Directed Acyclic Graph is that it's extremely fast once it gets going. But the cons are that with little activity, transactions will not get processed. And instead of 51%, only 33% of active traffic is required to take over this kind of network. Number 7. Byzantine fault tolerance, as used by Ripple, Stellar, and Dispatch. With Byzantine fault tolerance, pre-selected validators are in charge of the network, and no miners or community contributors are required. With that said, Stellar allows anyone to become a validator, while Ripple itself decides who validates blocks on their network. These are centralized services using blockchain technology. The pros of Byzantine fault tolerance are that they are very fast, private networks. The cons for Byzantine fault tolerance are that validators are merely using these blockchain networks. They are not part of them. Number 8. Proof of space or capacity, as used by Burst. Although only one coin currently uses this, it is an interesting algorithm. It allows people to mine using spare hard drive space instead of CPU and GPU cycles. Your hard drive space is filled up with small amounts of random files that act like lottery tickets. The network elects a winner every defined number of seconds or minutes and gives them a coin reward. It takes tiny fractions of energy, around 5 watts, to power a hard drive, compared to the 100 plus watts of a single GPU or 1200 plus watts of an ASIC, which is the specialized mining hardware developed just for Bitcoin and other major coins. Number 9. Proof of activity, as used by Decred. This is a combination of both proof of work and proof of stake. Currently, only Decred uses it, and the pros and cons remain to be seen. Number 10. Proof of elapsed time, as used by Hyperledger Sawtooth. With proof of elapsed time, every participant in the network is assigned a random time in each block, and whoever's time runs out first gets to create the next block. This network is called permissioned because prospective participants must identify themselves to the network, who will decide whether or not to let them participate. Clients on this network must be identified with their code passing verification trust, to avoid simply exploiting the time on the network node to trigger sooner. The pros and cons are yet to be determined. And yet there are still many more algorithms, which include proof of importance, proof of reputation, proof of weight, proof of evolution, and many, many more, which we invite you to explore in your own time.